Welcome to today's lesson. We're going to be taking a look at more quadratic inequalities. This time we're going to be graphing them as a system with two variables, y and x, not just on a number line, not just solving for x. We're going to be actually graphing them. First of all, just a few notes you want to get down. If I were to graph these two, notice it's not just y equals, it's not just a parabola. I'm doing greater than and less than or equal to. We have two inequalities here. Let's just start with the blue one, which is going to be the first one. A couple things we want to note. The blue equation has a greater than, but it's not equal to. If you don't have one that's equal to, you're going to use a dashed line. This is the same thing you did in Algebra 1, that if you had y is greater than x plus 2, and you graphed x plus 2, you wouldn't draw a straight line. You would draw a dashed line to indicate that it's not equal to. Same thing here. Notice my blue line in my graph is dashed because it's not equal to. This means that the points on this line are not solutions to this system because it's not equal to that line, just equal to the shaded area. Likewise then, the red equation, which is the second one, has a less than or equal to. It is equal to, and because it is equal to, you have a solid line. And notice the red line is solid. That indicates that those points who are on the line will work, as long as they're within the boundary of the region. So to reiterate that, if you have less than or equal to or greater than or equal to, use a dashed line. If you have just less than or greater than, sorry, I said that backwards. Forget those last 10 seconds. If you have less than or equal to or greater than or equal to, you use a solid line because it's equal to. It includes those points. If it's less than or greater than, you use a dashed line to indicate that it is not equal to those points. Okay, the next main thing that you want to get down in your notes is which way do I shade. Notice the blue graph had a greater than symbol. The red graph had a less than or equal to symbol. If it is greater than, you shade above. If it is less than, you shade below the line. So the blue one was greater than. So from any point, if you went straight up, because we're talking about y being greater than, go straight up for any of these points. So that shaded region is going to be inside the parabola, because that's the part that's above the line. The red one is less than, so we're talking about points below the line. So I'd be shading below the line. Now, when you do this on paper, it might look something, if you have colored pencils or something like that, that's even better. Once we sketch this graph, and we sketch this graph, which goes way down here, I'm shading above the line on one, and I'm shading below the line on the other. And what we're looking for is the overlap region, because where the two overlap is where the system has a solution. So while this area is blue and this area is red, it's the region that's overlapping, or this area, that's the solution region. Okay? Again, on paper, it's going to look something like this. So I have the one line, I have the other line, and I say, okay, well, I'm shading below the one, and maybe you just lightly shade below the one, and then you shade above the one. Where is it overlapping? Where is that crisscross occurring? And it's only inside this shaded region where they meet. Okay? So be careful while you're shading and look for the overlapping region. Sometimes you don't have to shade all of it. Sometimes you can just reason it out. I'm looking for an area that is greater than the blue line, but less than the red line. Okay, so what region? Is this region greater than the blue? Yes. Is it less than the red? No. Is this region? No, this region is greater than the red, not less than the red. This region is below the blue. The only place that it's above the blue and below the red is this area in between. So if you can get right to shading in that area without shading all of it, that's fine. What we want your final answers to be, though, is not all of the shading. We just want to see the final answer shaded, and that's this region here. Now that means any point inside of here is a solution. So 0, 0 would be a solution. Any of these points in here or along the red line here are solutions. Anything outside of this region is not a solution. Like 9, 1 obviously would not be a solution to that system. Alright, so how is this going to look? What are you going to do? So you can use the calculator to help you. I'm going to take these two equations. We'll come back to their inequalities. I'm going to graph them. So I'm going to put the first one in y1, the second one in y2. And you can see that on my calculator. I already have that typed in. We're going to press F6 draw, and it will draw the two lines for us. Now if you don't have it centered, press F3, center it up, and then draw it. And it'll be nice and centered and you'll see them. In order to sketch these, we need at least one point, and the most crucial key point is the vertex. So I'm going to hit G-solve, maximum, and I'm going to do that for the blue line. So I'm going to hit execute, 0, 3. And then I'm going to hit G-solve, minimum. Now I don't want the blue line, I want the red line, so I'm going to hit the down arrow, hit execute, and it tells me that that vertex is -1, -4. So at least I have one point to help me sketch these. So now I'm going to sketch the two parabolas, making sure that one of them, the red one, is dashed, because the red one, the second equation, notice, was not equal to. It was just greater than. The blue one, the first one, is equal to. So I graph those. Now I did it on the calculator. You're going to do it on paper, so it's going to look something like this. I simply plot my, I'll do the blue line first, my vertex at 0, 3, and I'm going to draw it. Just a sketch. It doesn't have to be super accurate. I mean, if you want to get x-intercepts and stuff, you can, to be more accurate. And then I'm going to draw my second line with a vertex at -1, -4. -1, -4, and I'm going to draw it going up. Now the question is, where do I shade? The blue line, the first equation, said less than or equal to. So that's this one here. I'm going to go less than this line. But I need to be greater than the other line. So again, I'm going to be below the one, but greater than the other. That's going to be this region here. Only difference is I need to have this be a dashed line. Oh, I'm erasing the whole thing. Hold on. Let me just redo that. Because it's not equal to. Let me actually do blue and red. So the blue line coming down like this, vertex plotted at 0, 3. The red line, -1, -4, and it's a dashed line. And I'm just looking for a general sketch, as long as it's close to what you see in the calculator. And then my shaded region. Now you can draw both. So that means I want to go greater than the red line. Well, greater than the red line would be everything above that red line. And I want to go less than the blue line. Well, less than the blue line would be everything in here. Look at where they're overlapping. Where they're overlapping is in here. So you want to shade that darker if you do shade both. Shade this darker so it's clear that this is the solution region and not the other stuff that's all shaded in. Okay? Ultimately, we would like it to see like this. If you can get it so that you don't have to shade these at all, that would be ideal. We're looking for this as the solution in between those two. So which points are solutions? 0, 3 Yeah, that's right here on this point. That's a solution. How about negative 1 comma 0? Sure, that's a solution. How about negative 1, negative 4? Well, that's on the dashed line, so that is not a solution. 5, 7 is going to be up here. Not a solution. Negative 1, negative 9, or negative 9, negative 1, not a solution. These are the only two that are solutions. Okay, that's the bulk of the lesson. That's it. So if you're ready to go start the homework, you can. However, I'm going to show a couple more things to help. Let's say I had two lines that look like this, and they're both equal to. And one says, number 1 says that I want to be less than or equal to, and graph number 2, I want to be greater than or equal to. So what's less than this line? Well, it's not inside. Below the line would be everything out here, and I'll use red to do that. Everything outside of that first line. Well, I want to be greater than graph number 2. Well, what's greater than, I'll do this in green, this line? Well, that's everything above. So I'm shading everything outside of the parabola. So where are my overlapping regions now? Certainly not in the middle. That doesn't fit either. Not down here, not up here. What I'm seeing as the solution region that I'll shade darker are the outsides. So it's not always in between. It could be the outsides. There is a way to graph these on the calculator so that you can convert these types, type, convert, and turn these from our example, I want greater than, to turn them into inequalities. And maybe you learned this in Algebra 1. We hit type, convert, and this one was less than or equal to. And then when you draw it, you'll see the overlap region. Or they might show all the colors, and then you can easily see the overlap region there. So if you convert those using the calculator, it might even make it easier. If you want help with the calculator stuff, pop back in the live session.